In this tutorial, we're going to go over how to make the Titan 4M, which is part of the Titans of CNC building block series. Let's first take a look at the blueprint and see what's going on. Looking at sheet number 1 on our blueprint, we can see our basic shape is this triangle, and our triangle is going to be extruded 750 thousandths. In addition to that, the corners of the triangle have a little corner radius here of 50 thousandths. Moving on to sheet number 2, looks like we have 3 tapped holes in the corners of our triangle here. Moving on to sheet number 3. Sheet number 3, we have a triangular shaped pocket with some corner radiuses in here. In addition to having that triangle shaped pocket, the corners of our triangle are actually clipped off, and we can actually see that in our isometric view. And then in addition, we actually have this groove, this radius groove on the outside here. So let's jump over to Fusion 360 and we'll make this part. I'm over here in Fusion 360, and we're going to set this part up using a couple lines. So we're going to go L on the keyboard. Again, we have our triad, and these kind of like salmon colored squares represent the planes that we can sketch onto. These planes coincide with our view cube up here. Well, the plane that I'm going to start on is our top plane. Very first thing that I'm going to do is I'm going to sketch a line from our origin going straight up. And according to the print, this line is 2 inches tall. I'm going to click on it and press X, changing it to a construction line. After I have that line in place, I'm going to draw another line. This particular line here, I'm going to draw down below my origin, and this line is going to be 2 inches, 309 thousandths long. Now I want the center of this line to coincide with our origin, so I'm going to add a constraint. I'm going to go constraints down to midpoint. I'm going to click on the line itself and then our origin, and it will snap up to that location. Now all I have to do is just connect the dots. So L on the keyboard. I'm going to go from the tip of our construction line down to the end point of our baseline, and do the same on the other side. Now that we have our triangle, I want to make sure that the angle between this line and this line is exactly 60 degrees. So I'm going to go D on the keyboard, go from line to line, and drag that out. And notice we're getting this, this over-constrained pop-up window, and that is good. If I press OK and you zoom in, notice that our measurement is exactly 60 degrees. I can actually double click on this measurement here. Double click on it, and it's not letting me do it this time. But you can actually double check that that measurement is exactly 60 degrees. But because everything is fully constrained, it's not allowing us to do that. Now that we have our basic shape of our triangle, I'm going to finish my sketch, right click and press and pull so we can extrude this part. I'm going to click on my triangle and I'm going to type in 750 thousandths and then enter. Notice we have our primitive here. Once we have our primitive, we're going to take the corners of our primitive and add a 50 thousandths corner radius. So we're going to go to modify, down to fillet. We're going to click on all 3 edges that make up the corners of our part. I'm orbiting my part so I can get all 3 edges and type in 50 thousandths of an inch and then enter. We're done with sheet number 1, moving on to sheet number 2. Sheet number 2 has got some tapped holes on it, and we're going to have to lay those out. Very first thing that we're going to do is we're going to draw some construction geometry here. One thing we could do is actually turn on our, no, we won't be able to do that. So disregard that. So we're going to do some construction geometry. So I'm going to go L on the keyboard. I'm going to click on the top of the part here. I'm going to reference off of our origin again, and I'm going to go straight up. Doesn't matter where this endpoint is located. I'm going to change this to a construction line by clicking on it and pressing X. And then I'm going to add a vertical constraint to that line, ensuring that that thing is perfectly vertical. Fusion 360 may add an automatic constraint to it already. Just be mindful of that. Now that we have our construction line in place, what we're going to do is we're going to go to create and down to point. I'm going to land my point on that line. Then I'm going to land my other points over here, just like that. And then we're going to add some dimensions to them. So I'm going to go D on the keyboard, measuring off of the datum location and dragging out this measurement. This particular one is 1 inch 637 thousandths. Going from our datum, measuring out over here, and this one is 189 thousandths. And then one thing I failed to do is this point and this point are perfectly horizontal to each other. So we're going to add in a horizontal constraint, just like that. And in addition to the horizontal constraint, this point and this point are symmetrical to each other off of this line. So we're going to go to constraints, down to symmetry. We're going to click on point number 1, point number 2, and our line. So what that did for us is we only have to dimension one of those points, and notice as I'm dragging this over, that other point is going to move with it. So back to dimensions, D on the keyboard, going from our origin down to that point. And this one measures 828 thousandths. And notice that that other point will snap to that location. We're going to finish our sketch because everything is fully defined now. And we are going to change these points into tapped holes. We're going to go to create, down to hole, or H on the keyboard. We're going to click on all 3 locations. And now that we clicked on all 3 locations of those points, we're going to look at our blueprint. It states that our hole type is going to be countersunk because it's stated that there's a chamfer located there. Our hole tap type, they are tapped for threads. We see that with that designation of 10-32 unified fine. We are using a full depth of threads, and we are using a drill bit with an angle to create the hole to be able to place these threads into. So let's look at the hole pictogram here. The depth of our threads, according to the print, are 375 thousandths. So we're going to type that in. The diameter of our chamfer is 205 thousandths. We're going to type that in. The countersink included angle there is 90 degrees. We're going to disregard this angle here. This is actually the included angle of the drill bit that creates the hole. We're going to jump down to our size. Our size is 190 thousandths, or pound number 10. The designation is 1032 unified fine. Our class is 2B, which are internal threads with a mid-fit. And we are going to use unmodeled threads. We're making sure that this is unchecked. After you have all this information filled out, you're going to press OK. And we can zoom into our threads. You can see we have a chamfer here, and we have an image of threads here because we're using unmodeled threads. We're going to jump over to sheet number 3, which is our last sheet of this tutorial. Very first thing that we are going to use on this is we're going to create that rectangular pocket on the inside of our part. If you look on the left-hand side of the top drawing, it says that there's an offset of 174 thousandths going around here. So we're going to go and create a sketch. So create down to sketch. We're going to click on the top of the part. Make sure you are not clicking down here on your triad planes. We're going to click on the top of the part. And then we're going to go O on the keyboard for offset. We're going to click on the outer perimeter. And this blue arrows here, we're going to drag that in. And notice our data entry field here. We're going to type in negative 174 thousandths. And then enter. Notice now we have an offset going all the way around. That's exactly 174 thousandths. We're going to add in our corner fillets here. We're going to go to modify down to fillet. This one we're going to click on line number 1 to line number 2, line number 2 to line number 3, line number 3 back to line number 1. And according to the print, the radius of this fillet is 189 thousandths, and then press enter. The reason why I add all my entities in first before I add my dimensions is if I ever made a mistake, I can come back in and alter this one dimension and all the dimensions actually will update. All right, now that we have our geometry for our pocket, we're going to actually put the geometry in to clip the corners of our part. Be very mindful. There's some hints on here on the blueprint, upper left-hand corner. It says to get this step down, draw a 378 thousandths circle on center of this bolt hole and use it to cut the corner 375 thousandths deep. However, the bottom where the base of the triangle is, we're going to be making a 378 thousandths circle that's going to be tangent, not centered, tangent to both the outer lines here. So let's start with the top. So C on the keyboard. We're going to go centered here. Notice the blue little circle in the center. That's indicating that that is concentric. We're going to drag this out and type in our measurement of 378 and enter. We're going to make our 2 circles down here. This time, what I'm going to do is I'm going to draw my circles in here to make sure that we're not going to get any automatic constraints. So 378, enter. 378, enter. And again, it doesn't matter where your circles are, we're going to add some constraints to them. We're going to go to constraints and down to tangent. We're going to click on the outer portion of our circle and then the outer line, and notice how that circle will snap to it. Same thing, circle to the bottom of our triangle and it snapped to it. Notice the color of our circle has changed. It's gone from blue to black, indicating that it is fully defined. We're going to do the same thing on the other side, just like that. And now we are ready to press and pull. One thing before we move on though is notice the color of our circle has changed, or our triangle has changed in here. And the reason why it's changed is our dimension has disappeared. So all I'm going to do is add that dimension back in to ensure that we have 174 thousandths. Whoops. And then I'm going to add it in on all these sides. Just making sure that all these things turn black, and so they're fully defined. We're going to stop this sketch, right click, press and pull. The area that we're going to start with is the outermost portion of our triangle, and we're going to clip these corners. So I clicked on all three corners here, and according to the print, we're going to bring these corners down 375 thousandths, so minus 0.375, enter. So notice now the tips of my triangles are cut off. I'm going to go back into my browser window. I'm going to open up my sketches, and then I'm going to turn on sketch number 3. Right click, press and pull. This time I'm going to press and pull our triangle in here. However, be mindful that you are also including these little areas down here. Otherwise you'll get a pocket that doesn't look right. So we're clicked on all the geometry that makes up that triangular pocket. According to the print, the pocket goes down 650 thousandths. So I'm going to go minus 650 thousandths and then enter. As soon as I'm done, I can turn that sketch off and take a look at my geometry. Lastly, we're going to create those the grooves on the outside of our triangle here. We're going to create another sketch on top of the part. This time we're going to use a circle, C on the keyboard. We're going to click on the top of the part. Make sure you're not clicking on these planes down here. You're clicking on the top. And this time what we're going to do is up in this outer space here, we're going to draw a circle. And according to the print, this circle is going to have a radius of 2 inches. So we're going to type 2 and then multiply it by 2 to give us a diameter of 4 inches. With that in mind, the center location of this circle has some dimensions stated to it. So measuring off of our origin here, we're going to click on the origin and then click on the center. We're going to drag this measurement down and we're going to type in 2 inches, 222 thousandths, and then enter. In addition to having a horizontal measurement, it also has a vertical measurement. We're going to repeat the process, but this time dragging our mouse either to the left or the right, doesn't matter. And we are going to type in 1 inch, 949 thousandths, and then enter. All right, so now that we have our geometry in place for our circle, what we need to do is we need to land a location somewhere up in the center of our triangle, and we are going to do a circular pattern off of that location. So I'm going to go to Create and down to Point, and I'm just going to land a point kind of in the center here. Before I add some dimensions here, I'm going to add a constraint. This point shares a relationship with our origin. They are perfectly vertical to each other. So I'm going to go to Constraints, down to Horizontal and Vertical. I'm going to click on my point and then click on my origin. And now it is perfectly vertical to it. In addition to that, we're going to add our dimensions in from our origin to that point. This measurement needs to be 667 thousandths and enter. Now that we have this point here, this is our center of rotation. We're going to rotate and do a circular pattern. We're going to go to Create, down to Circular Pattern. The pattern, or the object that we're going to pattern, is this big circle here. So we're going to click on the big circle. Then we're going to select our center point in our pop-up window and choose the center point or center of rotation point that we just created. The amount of instances of the circles that we're going to create is 3, so we're going to leave that alone and then press OK. Now that we have our geometry in place, we're going to do some pressing and pulling. So right click, press and pull. We're not concerned too much about this portion of the circle. We're concerned with this little sliver of the circle. We're going to click on all three of those portions of that circle. And then we're going to take a look at our pop-up window. According to the print, the bottom of this groove from the top of the part is down 375 thousandths. So it's offset down 375 thousandths. Well, I'm going to go to Start, down to Offset, and I'm going to type that measurement in here, minus 375. Now, the distance from that location going up is 125 thousandths. So I'm going to type down here where it says distance, 125 thousandths. And notice Fusion 360 automatically recognizes that we're going to cut this. After you fill out that information, you can press OK. And you should be able to orbit your part around and see 3 grooves that are on the outside of your part. Almost done with this part. If you look down in the title block, it says unless otherwise specified, remove all burrs and break edges 10 thousandths. So we're going to do this using a chamfer. We're going to go to Modify and down to Chamfer. We're going to click on all the edges of this part that could possibly be sharp. So we're going to click on this edge, the outer edge, including that radius, the top of the notches here, the top of the notch on this side, and the bottom of the part. Now, some students have asked in the past, well, what about the groove here? Why can't we chamfer this? You can chamfer it. The biggest thing is you got to start thinking about a machinist. How would we make this? There's several different types of ways that we can make this. If we were using a 5-axis machine, we could actually orbit this part over and then chamfer this edge here. On a 3-axis machine, we can make a series of soft jaws and rotate the part in there. We could actually, if we were using a 3-axis machine, we could actually have a custom key seat cutter cut for us. That would actually include the chamfer in here. But that would be a little bit more difficult. They also have some chamfering tools that could reach in there and touch that geometry. It's really kind of up to what the customer is wanting. For the sake of this tutorial here, we're just going to disregard that. For one, you can't see that in the isometric view on the blueprint. So I assume that Titans of CNC Academy is disregarding that also. We're going to type in 10 thousandths for our distance here, and then press OK. Double check your part and make sure it looks very similar to what the isometric view looks like. Make sure you got all your geometry correct. This is a good time to save your part. Make sure you're saving it as the Titan 4M. And this concludes the tutorial on how to make the Titan 4M.